Hello guys, I hope everybody is able to hear me. How are you all? I hope you're doing fine. Absolutely fine. We'll just start the session. Can you hear me, guys? Hello. Okay, perfect. So please hit the like button before joining as usual. Okay. So today's session, we will be continuing the discussion where we have left yesterday. And probably I also want to discuss about some of the things which I have missed. And then we'll try to cover that. We'll also try to see some kind of practical examples. Okay. So all those things will probably get covered. And yes, let's go ahead, and probably we'll wait for another 5 minutes so that 7 o'clock we can start the session, right? But before going ahead, I hope everybody have seen my Hindi playlist on Krishnaik Vlogs channel. So you can go ahead and see that also. I've started uploading videos on that too. Okay, please make sure that you subscribe that so that you'll be able to see those videos also. Yeah, day 5, day 4 resources. On day 5, day 4 resources are uploaded. I'll just have a look. Okay, I'll just have a look. Probably uh, if I'm able to find it out, I will definitely do the necessary changes, but it'll take time. Okay, so day 5. Guys, but if you go down, you will be able to find everything over there, no? Not, it is not the same resources, it is the continuation resources. Okay, so in the next sheet you will be able to find it out, right? So please make sure that you watch those. They are uploaded. You can go down. It is the continuation, like this is the same sheet I'm talking about, right? So here you will be able to see this was day 4, right? And day 5 we started from here, right? So please do that particular part also. Okay. A to B testing becomes now easy, right? If you know all these conditions. Yeah. Let's see. I will take an example tomorrow. So today is the sixth day live session. Shall I use a new sheet? Let's go ahead and use a new sheet. Okay. So sixth day live session. Okay. So today, what all things we are going to discuss? Okay. Today, first of all, we will continue with the discussion where we left. So we will solve a chi-square problem. Okay. The second thing that I forgot about some of the topics over here is with respect to covariance, correlation. Congratulations, Ramesh. He got an offer from TCS. Amazing. Congratulations, guys. Just say him congratulations. Pearson correlation coefficient. And the Fourth topic that we are going to see is nothing but Spearman rank correlation coefficient, right? We are going to just a second. Spearman rank correlation coefficient. We are going to discuss about this. Then probably we are also going to see practical implementations. Okay, so we are also going to check out some practical implementation things. Okay. Now in this practical implementation, we will try to perform Z test, T test, and probably also see how to perform chi-square test. Okay. I have taken entire course 2 days back. Which entire course are you talking about, Amar? Guys, my voice is not low. I can hear this in my YouTube channel. It's quite high. Okay. So I don't think so. My voice is low. Is my voice low? Is my voice low, guys? So this is what we are going to discuss. Guys, my voice is full high. I can check it out. Okay, my voice is absolutely fine, I guess. Okay, so for the people who cannot hear me, okay, so just try to increase the volume of your laptop or your desktop or use earphones. That would be amazing. Okay, okay, perfect. So many people can actually see this. Okay, this topic we will also see F test, which is the last topic, which is also called as ANOVA test. Okay, the reason why I've kept F test as large because the calculation will be very the calculation is quite complex in that particular case. Okay. No, guys, I think I've set the volume high so everybody is able to hear. Many people are able to hear it, I guess. Okay. Okay, guys, so let's start. The first thing first, let's go to the chi-square test and let's solve a problem. I hope my energy level is quite high because it is a 7 day session, sometimes you feel low, the energy becomes low because same thing but the plan is to basically cover everything in such. Okay, so now let's go ahead and let's try to discuss about the chi-square test. Chi-square test has quite amazing problem statements. Okay, so if I really want to discuss about chi-square test, it is mostly I'll talk about it. Okay, right now. So let me just define what is exactly chi-square test. Chi-square test. Okay, so the chi-square test claims about population proportions. That basically means if someone asks you, Krish, someone asks you in the interview, why is chi-square test used at? Why it is used? You can just say that it is a non-parametric test that is performed on categorical variables. Categorical, it can be nominal or ordinal data. Okay, so this is how you basically define a chi-square test. Okay, everybody clear with this at least till here? Yes, Amar, Oneneuron Lifetime subscription will be more than sufficient to clear your data science things. in one of the courses. There are around 1100 videos which covers the complete data science from deployment to big data to everything. Okay. So it is a non-parametric test that is performed on categorical or ordinal data. Okay. So this is what chi-square test is basically used. So if probably they ask you in the interview, make sure that you are basically understanding why a specific test is actually done. This is very, very important. Okay. Because in the interview they may give you a problem statement and they may ask you what will be your plan to solve that specific problem statement, but with respect to definition you should definitely be able to tell them. Okay, now let's go ahead and let's solve a specific problem. For solving this specific problem I am just going to take a chi-square test problem. Okay, let's say that I'll take a very good example. So this is my question. In in the 2000 Indian census, Indian census, the ages of the individual, the ages of the individual in a small town, in the small town were found to be the following. Okay. Now over here you have three categories: less than 18 years, 18 to 35 years, and greater than 35 years. So you had this information in the 2000 census. Okay. So this was the information that is basically present in 2000 census of a small town. That basically means less than 18 years were basically 20%, 18 to 35 were somewhere around 30%, and greater than 35 was somewhere around 50%. Okay, so this is the information that is given from the complete census. Okay, now with respect to this, I'll continue the statement, guys, and this is a big question, so please make sure that you write it down. Okay, write it down completely. Okay, so considering this, in 2010, in 2010, okay, ages of sample n is equal to 500 individuals were sampled. Below are the results. Below are the results. Okay, so we basically have three columns again. That basically means in 2010 again they took a sample of 500 people and they found out this was the basic results. Let's see. So out of those 500, less than 18, 18 to 35, and greater than 35. So less than 18 were 121 people, 18 to 35 were 288 people, and this was 91 people. Okay. Okay. So so the question is so the question is now, what is the question? Using alpha as 0.05, would you conclude the population distribution of ages the population distribution of ages has changed in the last 10 years? So this is the question that is basically given to you. The question is very much simple. It is saying that in 2000 census, I'll just make my face smaller so that you can focus over here. Okay. In 2000 census, the Indian census, the age of the individual in a small town were less than, this is basically the data. This is the population information. Like less than 18% were 20%, 18 to 35 were basically 30 percentage, and greater than 35 was 50 percentage. Okay. Then in 2010, the ages of n is equal to 500 individuals were sampled. Below are the results. Then in 2010, what happened is that, you know, this again they again found out by picking up 500 people as a sample data, and they found out that less than 18 were 121 people, 18 to 35 were 288 people, and greater than 35 were 91 people. So using alpha is equal to 0.05, would you conclude the population distribution has changed in the last 10 years? So this is the exact question over here. I hope everybody understood the question, guys. Yes, yes. If you have understood the question, hit like. I can see very less likes. Why? Like daba do. Okay. Everybody clear with the question? Everybody clear with the question? Quickly, guys, tell me. Okay. Now, what we are going to do over here is that we are basically going to solve this particular problem. Now, you may be thinking that, Krish, you have told that it is a non-parametric test that is performed on categorical, that is nominal or ordinal data. Now, what exactly is non-parametric test? Non-parametric test usually occurs with respect to population proportion. Whenever you are given some kind of proportions of data, at that point of time, you cannot specifically use a kind of parametric test. So you have to go with non-parametric test. Okay. Now, here you can actually see that when this is the original data with respect to the population, then you sample the data and you found it out, right? And then we are just trying to see that what is the difference between this to this, okay, this to this. Do you think the population may have probably changed just by seeing the specific data, or still you will probably just say that, yeah sir, it may be population has changed, probably 18 to 35 you can see a huge quantity or number, greater than 35 just seeing the percentage it shows a very less number. Obviously from the above population proportion you should be saying that greater than 35 should be more. um, in this particular scenario, what kind of assumptions we can make? There is two kind of assumptions, whether the population distribution has changed or whether it has not. So how to go ahead and approach and solve this particular problem? Okay. So here I am going to basically start the answer. Okay. So the first step, what we are going to do as usual, you can, let's go ahead and let's make two tables first of all. So this is my first table. Okay. This is my second table. Okay. Because this table will play a very important role, guys. Okay. The first table basically have the population information. So I'm just going to draw it over here. Okay. Here I'm going to basically say less than, this is less than 18, 18 to 35 and greater than 35. Okay. Now this is the expected. See why I'm saying expected, because this is the population information. This is the population information. So here less than 18 is 20%, this is 30%, and this is 50%. Now this is what your entire distribution is expected to be, because in 2000 US Census they found out this data. Now, right now after 10 years when they took the sample of n is equal to 500, this is the observed one. Okay. So the observed one was less than 18, less than 18 was 121, 18 to 35 was 288, and greater than 35 were 91, right? So this two information you definitely have. The reason why I'm drawing this two or writing this two information, okay, we will be able to understand it. Now we will create one more table, and the table is something called as expected. Okay. this is the observed one, right? Now what I'll do, I'll create one more field. Okay, and let's say based on this, suppose if I take n is equal to 500, based on this, what should be our expected? What should be our expected distribution based on this data? If I'm picking up 500, so we will try to divide this based on this percentage, right? So here my value will be 500 multiplied by what is 20% is less than 18. So I will multiply by 0.2. Here I will say 500 multiplied by 0.3. Here I will say 500 multiplied by 0.5. So this should be my expected distribution based on 2000 census. Observed is this one, that is fine. But we really need to find out our expected also, right? So if I multiply this two, so if I multiply 500 multiplied by 0.2, this is basically 100, right? So here I'm basically going to write 100, right? This will be how much? This will be 150 and this will be 250. This was what was the distribution I needed to have, right? Based on the 500 data, based on this 2000 census. But this is what is observed, right? So now let's go and focus on this two table right now. Okay, so we have got 100, 150, 250. Obviously there is a huge difference, and by seeing this only you will be able to say that okay Krish, there is a huge difference here. Only I can definitely say that okay, just reject the null hypothesis. But understand over here alpha is basically given. I want 95% confidence interval. Okay, why multiplied? Again understand why multiplied, because we need to find the expected distribution based on this data from this 500 sample, right? So if I consider 500 sample in 2010 also, I need to get this data 100, 150, 250. Is it clear everybody or not? Everybody is clear with this? Just let me know. So I'm going to draw this table again. Okay, so I'm basically going to say this is my, I hope everybody is understanding, guys. This is my observation and this is my expected. Okay, so this here has less than 18, 18 to 35 and greater than 35. Okay, so less than 18 is how much? I have basically 121, 288, 91. This is the observation, and then I have 100, 150 and 250. Okay, now these are my three categories. This is one category, this is two category, and this is the third category. Now let's go ahead and let's try to understand what is the next step. Okay, now next step, I will first of all, obviously you have to define your null hypothesis, alternate hypothesis when you start the hypothesis testing. So let's say that my null hypothesis is that the data meets the distribution. This is the data, right? This is the data, observation data. It meets the distribution of 2010 census. Of 2000 census. My alternate hypothesis will say that the data does not meet the distribution of 2000 census. So I hope everybody is able to understand the null hypothesis and the alternate hypothesis. Okay, so this is very much clear, very much simple till now, nothing so fancy. Okay, then the second step is my alpha value. My alpha is 0.05. That basically means 95% confidence interval. Okay, so this is also very much clear. Now the third step in this is that whenever we do a chi-square test, we also need to know the degree of freedom. So how do we calculate degree of freedom? This is the steps, guys, and always this will be like this only. N minus 1. What is n over here? N is nothing but this is 1, 2 and 3. This is where number of categories are coming into picture. Okay, categories are coming into picture, 1, 2 and 3. So 3 minus 1 is basically 2. Okay, Now let's go to the fourth step. Everybody clear till here? Age is now categorical, right? Absolutely perfectly fine. Okay, great. You are in the right path. I'll make you an offer which you cannot refuse. You are in the right path. Okay. Now you know your degree of freedom. Your degree of freedom is 2 and your alpha value is 0.05. All you have to do is that go and check in the chi-square table, okay, to find out your decision boundary. Is this a one-tailed test or two-tailed test? First question to you all. Is it a one-tailed test or two-tailed test? Obviously, if you know this, what I'm actually talking about, the data may be less than your distribution, it may be more, right? So here is this a two-tailed test. Okay, because alpha is 0.05. Guys, we have to pick 3 as n because there are 3 age categories. Okay, so this will become a two-tailed test. Now in two-tailed test, all I have to do is that open a chi-square table. Let's see. Chi-square. Chi-square table. Now this is my chi-square table. Hope so I get the answer quickly. So df is 2. Or to look upon an area on the left, subtract it from the 1. Just a second. Point 0.05. See, 0.05 is here and degree of freedom is here. So this becomes 5.991. Okay, 5.991. Here you can directly see this. It is 5.991. Okay. So over here, we usually mention chi-square by x square. Okay. And chi-square is basically denoted by x square. And my decision boundary is that if chi-square is greater than 5.99, I have to reject H0. Clear? Okay, 5.99. Now let's go and compute the chi-square test as usual. Very simple definition. So my definition will be that fifth is calculate the test statistics, which is called as chi-square test. This is nothing but x square is equal to summation of f0 minus fe whole square divided by fe. Again, notation can be used in all different ways, but let me talk about what is f0. F0 basically means observed. Okay, observed. Fe basically means expected. Okay, so I am going to do the summation of all these three values. So here I will first of all write 121 is my first observed value. See, 121, 100. So 121 minus 100 whole square divided by 100. Then if I go to the second element over here, you can see 288 minus 150 divided by 150. So 288 minus 150 divided by 150. Okay, whole square. Then third one will be 91 minus 250 whole square divided by 250. So this will be 91 minus 250 whole square divided by 250. So quickly do the calculation and tell me what is your x square. Okay. Uh, No, Tamanna, we are not. See, understand how chi-square table looks like. There you will be able to see 0.05. So basically, you have to check it in 0.05. There you don't have two part. Okay. So what will be the output? Quickly tell me. Yes, one guy has absolutely sent me right. 232.94. That basically means my x square is 232.94, which is obviously greater than 5.99. So what we have to do? We have to reject the null hypothesis, and which is absolutely true because the population distribution has changed. Okay. So this was my final outcome. Okay. Yes, Nimai Ghosh, I will also show you in Python. Don't worry. So 232 is greater than 5.99. So we are rejecting the null hypothesis. Okay. So was everybody able to do it? Okay, it is 494. Huh? Okay, let me write 494. 494. Okay. Yes, Pratik, absolutely right. Always understand that you really need to see that how your table looks like, chi-square table and all. Again, that can also be done manually. You have to basically use multiple formulas and do it. Nirop Sarkar, just search for chi-square table. This is how chi-square table looks like. From 0.05, okay, degree of freedom is 2. So I am getting 5.991. No, it will not be 0.025. दूसरा टेबल भी दिखा देता हूँ रुको. Let's see another tables. Less than critical value 0.05. 5 point. See, if I subtract 1 by 0.05, it will become 0.95, right? So here also you can see that it is showing 5.991. Here also same thing in it. To look up on the area on the left, subtract it from 1 and don't look it up. That is 0.005 on the left is 0.95 on the right. So here when you see there are two tables. One table is this, one table is this. Yes, sometimes I find this table a lot of confusing, you know, because there is no one specific thing. Yes, Sumit, see, that only I'm actually telling you. If you are looking for two tail, your data in the table also should be shown in the form of two tail, right? If it is not shown in the form of two tail, then how probably you're going to do it? Okay. So if you want to define chi-square, it claims about population proportion. You can just say that it is a non-parametric test that is performed on categorical, nominal or ordinal data. Okay. It is specifically applied on nominal or categorical data. Okay. Now let's go. Python is pretty much easier. Python, you don't have to do much anything. You want to see one Python example? You want to see one Python example with respect to Z test? I can show you that. Okay, let's see one Python example. Okay. So I'm just opening this. Okay. Let's say that in my, I want to perform Z test. Okay. So let's say that I have some values like this. So this is my question. Suppose the IQ in certain population is normally distributed with a mean of mu is equal to 100 and standard deviation of 15. A researcher wants to know if a new drug affects IQ level, so he recruits 20 patients to try it and record their IQ level. Okay, now I'm going to show you the code, okay, in Python to determine if the new drugs causes a significant effect or not. So I'm just going to execute this, okay, and let's say that I have this 20 records. For Z-test, we use this library, which is called as statmodels.stats.weightstats, import Z-test as Z-test. So these are my 20 patients, okay? And I have recorded the IQ after the medication is basically applied. Now, in order to apply Z-test, no need to do that much calculation. Just write Z-test, Z-test, and here just give the data, and the next parameter that you will probably be giving is this IQ, that is 100, okay, which you are actually trying to compare, okay, to basically reject or null hypothesis or not. In this, the null hypothesis will be mean is equal to 100, mean is not equal to 100, okay. Now when you execute this, now here let's consider that I think the library is not there, or tuple index, what is the problem? Just a second, see to it, what is the problem? Okay, value is equal to 100, I have to write. So here let's consider that my alpha value is, see, let's see this, these are the two values that I'm getting. The first value is the Z-test value, the second value is the p value. What does this p value basically mean? Now many people were asking the difference between significance and p value. In Z-test, they try to give us some kind of p value. Here they also give the Z-test value. The Z score that you are able to see is here, and this p value. This p value can be used along with significance value. And suppose right now the p value is 0.001. Let's say that 0.11. This 0.11, suppose if it is less than significance level. Now in this particular case, let's consider that I'm going to take a significance level of 0.05. So if this is less than this, then obviously this, we reject the null hypothesis. This is just saying that based on this p value, it is basically falling in this region, so that is the region it is less than 0.05. Okay, so it obviously gives two value here. Just for understanding purpose, we can definitely use this value and try to do the remaining calculations if you want, because this is my real Z-test value. Other than that, this value will basically help you to compare with the p value and then decide whether it has got rejected or not. Okay, so this was one example with respect to this. Clear? Okay. So I can give you the entire code in the, okay, since it is 0.11, this is less than 0.05, we are going to reject it. Suppose if we get 0.005, let's say that in this particular case, I am going to use the mean as 110. Now you see I am getting 0.002. So do we reject or accept the null hypothesis? In this particular case, do we reject or accept the null hypothesis? Here in this particular case, if I go and probably see, you will be able to see I am getting 0.0002. 0.002, which is obviously less than 0.05. So we accept the null hypothesis. Accept the null hypothesis. This is obviously not, right? Not less than. So we reject the null hypothesis. This is not less than. 0.11 is greater than 0.05. So we reject the null hypothesis. I was saying it is not less than. It is not less than. Okay. Alpha can vary. You can have 0.01, you can have 0.10. It depends on the domain. Okay. Now you saw one example. Now let me discuss about the next point, which is called as covariance. Okay. Yes, if p-value is less than, if p-value is less than significance value, that basically means it falls in the tail region. So we reject the null hypothesis. Right? So we reject the null hypothesis. If it is greater, then we accept the null hypothesis. If it is greater, we have to accept, or I'll say we accept the null hypothesis. Yes, in medical domain, it can be depending. Okay. Let me start about covariance now. Shall I continue, guys? Till here clear? Now, like that, you can do for t-test. What all data you require? See, whatever a question I am writing with respect to this, that kind of data you require. Now, in this case also, when I gave this problem statement, here you can see that, right? I have written the same type of question. Suppose the IQ in this is there. So he recruits 20 patient. This is the 20 patient data, and I am basically checking out the Z test. Manoj Gayawali, here we consider an alpha value, no? That only we assume one alpha value, right? Yes, Venki, we never say we accept null hypothesis. Instead, we can say we fail to reject null hypothesis. Okay. Now, in order to make you understand, I'll say like that only, no? We fail to reject the null hypothesis, or we reject the null hypothesis. Pranavnath, Z value, like significance value, is decided by the domain expertise. Yes, absolutely right, Sumit. So if mean IQ before meditation is 110 and p value is 0.002, it means that even after taking medication, the IQ will be around 110. It means medication has no effect. Yes. With respect to that specific thing, let's say that it has got medication has been applied before the IQ was 110, and after giving this medicine also it was near 110. Okay. Alpha and significance value are one and the same. No, 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 no. Understand one thing. Clear? No, guys, understand one thing. What I'm saying. See, you are getting confused in many things because the reason is that you're not focusing on what I'm teaching. Okay, let me define once again. Uh, Let me talk about Avadhut Dalvi. Okay, see this. This is my graph. Okay, this is this. Initially, I got 1 1. This was my p value. This is obviously greater than 0.05. Okay, and let's consider about p value as 0.002, which is less than 0.05. When I have this scenario, this basically means I am in the confidence interval. Okay, if I am having this scenario where it is greater than 0.05, I am falling in this, in the tail region. Okay, I hope now you are able to understand. If I am having this scenario where the p-value is less than significance value, I am in the confidence interval in this 95%. If I am over here, that basically means it is greater than the significance level. Clear? Understand one thing, okay? Yes, if p-value is less than, we do not reject, right? In this case, we accept the null hypothesis. We fail to reject the null hypothesis. We accept null hypothesis. I have explained that thing only, no? Okay, in this particular case, we reject. Okay, guys, now let's not go round and round. If you're not able to understand, I would suggest revise it. Okay, now let's go ahead and discuss about the next topic, which is called as covariance. Let's say that I have two data set, the two columns, okay, x and y. So if I have these two columns, let's say that this is basically my weight and this is basically my height feature. Okay. Riju, I will hide you from here permanently. Okay. If you don't want to attend the session, you can get lost. Okay. This is not how you should message over here. Here only serious people are coming and studying. I know you are not good for anything. You don't know what, I don't know why do you come over here also, simply wasting your time, wasting your internet, everything. So I have hidden you permanently from my channel. I have an option where I can put a condition where then if I want a person should not watch my YouTube channel, I have that. If you're coming here to make some mockeries out of it over here, not interested in studies, you can get lost. Okay. Okay. So let's consider weight and height. So in this particular scenario, okay, in this particular scenario, let's consider that you have some weights. Let's say you have like 50, you have height like 160 centimeters, then you have 60, 170 centimeters, then you have 70, then you have 180 centimeters, and then probably you have 175, you have 181 centimeters. Okay. Now in this particular thing, you can what kind of things you are seeing? What kind of relationship you are seeing? When x is increasing, y is increasing. Can I say this? When x is increasing, y is increasing. Can I say this? Can I say this? When x is increasing, y is increasing. And similarly, can I say when x is decreasing, y is decreasing? So both this relationship will basically follow this specific thing based on this particular data. Yeah. So when x is increasing, y is increasing. When x is decreasing, y is decreasing. Suppose let's say that I have one more data set, weight and height only. Let's say I have let's consider that number of hours study and number of hours play, right? Now in this particular case, if I am studying for 2 hours, let's say I'm playing for 6 hours. If I'm studying for 3 hours, I'm playing for 4 hours. If I'm studying for 4 hours, I'm playing for 3 hours. In this particular case, what is the relationship? You can see that when x is increasing, y is decreasing, or where x is decreasing, y is increasing. So this relationship is basically used over here, right? So here you can see these two conditions, right? These two conditions. Now, this is what you can observe. But the main thing is that how do I quantify? How can I quantify or show some relationship? Quantify relationship through numbers between x and y. Now, in that particular case, I can use a formula which is called as covariance. Now, covariance is basically given by COV x comma y which is nothing but summation of I is equal to 1 to n x of I minus x bar y of I minus y bar divided by, let me just check out covariance formula. It has been many days. And it is not important to remember the formula, okay? Divided by n, okay? So this is basically the formula with respect to covariance. If you are working with sample, again this will be n minus 1. Right now, let's consider that we are working with sample. Now in this particular case, you can see what is happening. Covariance of x comma y. Covariance of x comma y is nothing but x minus x bar. X bar is nothing but the mean of x. Y minus y bar is the mean of y. Now when we calculate, you will be able to see either we will get a positive number or a negative number, or I may get 0. Okay. Now tell me, what does a positive number basically indicate? So positive number, positive value indicate two things. One is when x is increasing, y is also increasing. When x is decreasing, y is also decreasing. So this shows if this positive number is basically coming, it basically shows, or it basically quantifies the relationship between x and y in this particular way. That basically means when x is increasing, y is increasing. When x is decreasing, y is decreasing. Okay. So here you will be able to see with this with a positive number. Okay. Now similarly with a negative number. Okay. With a negative number. So with a negative number, here you can find out that when x is decreasing, y is increasing. When x is increasing, y is decreasing. So this relationship you will be able to find out. Okay. So this is nothing but positive correlation, I'll say, and this will basically be negative correlation. Right. So here you will be able to see this. If it is 0, that basically means when x is increasing, y is not increasing, or probably there is no relationship between x and y. Okay. There is no relationship between x and y. Okay. So understand this particular thing. Okay. But let's understand with respect to covariance. Like suppose if I have a data set which looks like this. Okay. So I have a points which looks like this. Now in this particular case, if this is my x and y, what do you think will this be? Whether it will have a positive correlation or negative correlation? What it will be? Think over it. It will obviously have a positive correlation, right? Because here when the x is increasing, y is also increasing. If the y is decreasing, x is also decreasing, right? Both this condition are getting satisfied. Okay. So here you can definitely see this positive correlation is there. And when you are trying to apply this particular formula, you will either get a positive value in this particular case. Suppose if I have another graph which looks like this, this is my x and this is my y. Okay. If I have some data points which looks like this, now in this particular case, what type of correlation you will have? You will basically have a negative correlation. Sorry, I should not say correlation over here. I'll say negative. Okay. For now, because we have not started correlation, but here you will be having some negative correlation. Okay. I can also say it as negative covariance. Okay. Suppose if I have another data set which looks like this with respect to x and y. If my data set is like this, then what will be my value of covariance? Covariance will be 0 because there is no relationship. Okay. Covariance will be basically 0. Okay. So here you will be able to see all these things, right? Covariance in this particular case, it will be 0. Okay. Now let's understand one basic disadvantage of covariance. Okay. One basic disadvantage of covariance. Now covariance over here, you will definitely be able to see positive or negative. You will be able to find out the positive or negative correlation, right? This is perfect. But with respect to the disadvantage, there is no fixed value. You may have plus 100 also, you may have plus 1000 also, you may find out minus 200 also, minus 2000 also. Like this, with respect to the magnitude, there is no such limit. You will definitely be able to see the direction, whether it is positive or negative. But this magnitude is not limited. So if we have two distribution, how much positive, how much negative, that part, if probably if you have two distribution, one is plus 100, the other one is plus 1000, you'll not be able to identify because it is just a magnitude value. Okay, it is just a magnitude value. Now that is the reason we really need to restrict these values between some range. So for that specific region, we use another one which is called as Pearson correlation. Now Pearson correlation coefficient, what it does is that it basically restricts all your value between minus 1 to plus 1. Okay, the more towards plus 1, more towards plus 1 or minus 1, right, more positively it is correlated. Sorry, more towards plus 1, the more towards plus 1, more positively it is correlated. The more towards minus 1, more negatively it is correlated. Okay, now you should be able to see that. Okay, then what is the difference between covariance with respect to the formula? Now for the Pearson correlation, you can basically use something like this: x comma y. It is nothing but, it is very simple, covariance of x comma y divided by standard deviation of x and standard deviation of y. Because of this multiplication, all your values will be between minus 1 to plus 1. Okay, so here you will be able to see that it is always between minus 1 to plus 1. Now let me show you some examples in Wikipedia. Okay, let me just show you some examples with respect to Wikipedia. So if you go and search for Pearson correlation coefficient, here you will be able to see this. Okay, now tell me this particular diagram. Here you can see all the points are in one straight line. Okay, one straight line. So when you draw this particular line, your correlation, obviously in this particular case, when x is decreasing, y is increasing, right? In this particular case, if x is decreasing, y is increasing. If x is increasing, y is decreasing. This is the relation that is found. So it is negatively correlated, and if it falls all in the straight line, it is minus 1. Okay, then here you will be able to see that over here you have some of the data points distributed in this. Here also you can actually see negative correlation, but not all are in the straight line. So your value, your correlation will be ranging between minus 1 to 0. Okay, similarly in this particular case, here you can see that when x is increasing, y is also increasing. So here we'll have a positive correlation. Since it does not follow in the straight line, it is between 0 to 1. If it falls in the straight line, then it is plus 1. So it captures the linear properties very well, because everywhere you can see that there is a linear line. It captures it in an amazing way. That is the most advantageous things with respect to Pearson correlation. Now in this particular case here you can see that the correlation is 0. Why? Because we cannot identify when x is increasing, y is also increasing. The data is completely distributed here and there. Okay. Now some more examples. Here you can see this is 1, this is 0.8, 0.4, 0, minus 0.4, minus 0.8 and minus 1, right? So here you can basically see it. And similarly these all are 1, 1, 1, 1. This is 0, minus 1, minus 1, minus 1, right? And similarly here you can see some more zeros, right? You can also see some more zeros. This you cannot definitely identify what exactly is this. There is a lot of difference between covariance and correlation. So here your values will always be between -1 to +1 and nothing more than that. Okay. Let me search for one more thing, something called as Spearman rank correlation. Now you'll be understanding why do we specifically use Spearman rank correlation also. So I'll go to Wikipedia. Okay. I hope everybody understood about Pearson rank correlation. Sorry, Pearson correlation coefficient. Here, one thing that you have to identify, it captures the linear properties well. Linear, when the line is linear, obviously it will say you 1. Even though the distribution is like this, it will try to create a linear line and it will tell you the value. Okay. Now let's go to Spearman rank correlation. Now in Spearman rank correlation, just see this graph, everybody. Just see this graph. Okay. This graph over here that you are actually being able to see, this is obviously having a positive correlation because when the x is increasing, y is increasing. And when I try to calculate with respect to Pearson correlation, it is giving me 0.88. You will be able to see that at every point over here, at every point, when x is increasing, y is definitely increasing. In this region, it is increasing by a small amount, right? So this properties has not been able to capture by Pearson correlation. So that is the reason it is showing you 0.88 even though when x is increasing, y is also increasing. We need to get 1 and that is where Spearman rank correlation will come. Because Spearman rank correlation will also satisfy non-linear properties. Pearson correlation is good at satisfying linear properties that we have already seen, because if you see this example, it tries to determine the linear properties and tries to give the value. In this case, non-linear properties will also work well. Okay, so Spearman correlation, and what is the formula? Probably they will try to change it to the formula. Only one difference is there. Instead of writing, suppose let's say that I'm going to find out the Spearman rank correlation between x and y. Here everything will be same. Here instead of standard deviation of x, here you will be having rank of standard deviation of x multiplied by rank of standard deviation of y. Now you may be thinking, what is this rank of standard deviation of x and standard deviation of y? Let me just show you that also. So this is the formula. Okay, I missed one more thing. This will be covariance of rank of x comma rank of y. Now what is this rank of x and rank of y? Let's consider that I have this feature, weight and probably age. If this is 170, the weight may be 45. If it is 160, the weight is too high. This is not possible. So I will just say height and weight. Let's say height and weight. So if I say the height is 170, the weight may be 75 kgs. If I say height is 160, then the weight may be 62. 150, the weight may be 60. 145, the weight may be 55. Okay. Now in this particular case, how do I define my rank? This is my x, this is my y. How do I define my rank of x? Now rank of x is very, very simple. You just assign rank. Over here you have 4 points. Okay. Which value you want to give the highest rank? Go and see over here. This is having the highest value, right? Highest value. Okay. Now let's consider that I have one more, 180, and this will be 85. Let's consider in this, you just need to convert this, or you just need to assign rank to this particular data. Now rank basically gets applied to this. In height, if I say rank of x, 180 is the highest, right? So I may give this rank as 1. Then 170 is the next highest. Then 160 is the next highest. Then 150, then 150, 45, right? So here you will be able to see that I'm assigning rank. And similarly, I'll go and assign rank for y. In this particular case, my one rank is 85. Then you have 2. Then you have probably 3. Then 4. Then 5. Like this. This rank will be basically used to do this calculation. That is the reason I told, right? Covariance of rank of x and rank of y. Right? Divided by standard deviation of rank of x and rank of y. So this value will be taken. This will be completely ignored. Okay, so this is what is basically the entire Spearman rank correlation, and I hope you have understood. But understand, if someone asks you why do you use Spearman rank correlation coefficient, you should basically say that it captures the non-linear properties. It captures the non-linear properties. Okay, so I hope you have understood all these things. So we have discussed about so many topics now. This is done. This is done. This is done. This is done. Practical implementation, we will be seeing one more test which is called as t-test. Okay. Till here you have understood, guys? Yes or no? Yeah. I hope everybody is understood. Always understand, whenever you really have to convince the interviewer. The reason why I'm taking this is that because these are some of the most asked questions. Okay, and you should be able to explain them properly. That's it. Okay, how you're going to do it will not matter a lot. I hope everybody was able to understand, right? Now let's go ahead and let's try to do this one example. Okay, let's go and see something like t-test and try to do it. Let's see whether we'll be able to get or not. So here I'm actually going to show you t-test. Don't worry, guys, this materials will also get added in your entire thing. Okay, so suppose I have this ages. Let's consider I want to initialize this ages. So this is my ages. You can randomly initialize whatever you want because we are just doing a hypothesis testing. Okay. So it's up to you. If you want this ages also, I can ping it in the chat. So this is the ages. Okay. Now my main aim is that let's do one thing. Let's compute the mean of these ages. Okay. So ages underscore mean is equal to np dot mean of ages. So if I go and probably print ages underscore mean, so this is 30.34. Okay. Now let's do one thing. Very simple. From all these ages, let's consider that these are my population. I will just take a sample of age and then we'll try to verify whether we are coming nearer to this mean or not using t-test. Okay. Because here we don't know the population standard deviation. Okay, so let's do one thing. I'm just going to take my sample size as 10. Okay, this will basically be my sample size and I will just pick up all the sample from this particular ages. Okay, so I'm going to say np dot random dot choice. So here I'm just going to give my ages and this will basically be my sample size. So if I, okay, I'm getting an error. Okay, random np dot random. Okay, still error. Okay, random it became now. Insert random. My goodness. Okay, so here now if I go and show you my age underscore sample, here you'll be able to see that this ages have been picked. Now, can I basically, whatever mean is basically coming from this, can I actually come near to this population mean with the help of t-test? That is what I'm actually going to do. So I'm going to say from SkyPy dot stats import t-test underscore one sample. This we have done yesterday. Okay. T-test underscore one sample basically means one sample t-test that we have probably done yesterday. That is what we are going to do. Now t-test underscore one sam. Here I'm basically going to give you two things. One is my age underscore sample, and probably I want to give and compare with respect to this mean. Okay, so here I'm just going to give you 30. So here you can see that I'm getting the p-value as 0.76. If you don't believe me, just go and compute the np dot mean of age underscore sample. I'm getting 31.5, right? Which is little bit away from here. Now it is up to you. I got the p-value as 0.76. Now if I say my alpha value is 0.05. In this particular case, my p-value is greater than the alpha value. So tell me whether it should be accepted or rejected. Okay. Suppose if I execute the same code and I write sample size with respect to 31. Now I'm getting 0.918. Okay. Suppose if I execute with respect to this and I take up with my sample as 28. Now I'm getting 0.48. If I keep on doing this and make it to 26, here you'll be able to see 0.27, right? So this is with respect to different things. I can also even change this. Now if I go and execute this, here I'm getting 0.60, here I'm getting 0.45, here I'm getting 0.96, here I'm getting 0.67. If I try to change this random value again and again, let's say that I have taken now different sample. Okay, my sample is mean is nothing but 24.3. Now if I execute this, this is 0.015. It is, tell me, 0.05, right? Greater than 0.05 or less than 0.05. Okay. Now in this particular case, it is, if I say with respect to 31, this is 0.006. It is within that confidence interval or not. Similarly, if I go and see with respect to 28, 0.085, 0.397. So here you can basically see. And here I've just taken a small example. Okay. Here I've just taken a small example. Usually in the main scenario, you will basically have a huge data set to check out all these particular things. Okay. So this was an example with respect to t-test. Okay. You like the session, guys? Yes. Let's take one more example. Now I have a problem statement. I will consider perfect, guys. Thank you. Thank you. Thank you. I hope everybody is understanding. So like मार दो ना यार 500 तो कर दो. What I see, from this live sessions, now I'm thinking whether to take live sessions of machine learning or not. Okay. The audience becomes very less as we go ahead. Today is the 6th day. First day when people joined, it was around 1400. Okay. Then the second day it went around 1000. Then third day it went around 6 700. Today it is 348. Tomorrow I don't know, it should be 50 or 100. I don't know how many people will be there. So people lose interest. They'll say that, oh, Krish, upload everything, probably. And, it is, see, if the audience is not there, then probably just to put up 1.5 hour, machine learning will be like, I have to invest my entire energy, right? So that is the matter over there because, you know, it is difficult. See, machine learning, you have to basically write everything mathematically, showcase everything, so it becomes difficult. But anyhow, I will be taking, yes, very good example. This is a negative correlation. So day by day people are losing interest. I don't know, because of work or because of something else, you know yes, serious people will only attend at the last. Remaining all will be something like that only. Okay. So let's see. From Monday, probably I'm planning to start machine learning also. If not, I will try to do it from Sunday itself. Machine learning, 7 days. I will complete every machine learning algorithms by writing like this, like how I have written stats. Okay, it will be quite amazing. Okay. Okay, let's solve some different problem. Tomorrow, we are probably going to discuss about F test and probably all the distribution that exists that we should definitely know. So that will basically give you some kind of confidence and all. And yes, after machine learning, I'll also take deep learning 7 day session. Then I'll probably take up Flask, Django, SQL. Already I'm uploading it. Many things are there. So yeah, this is also a very nice idea. Don't put the recordings. So what I am actually going to do is that after making live, I'll make it hidden only to some people. Okay, that will be great, right? Okay, let's consider another example. As usual, probably this may be our another example. So my example is that suppose I take college, the ages of the entire college student. Suppose I take ages of the college student right? Right. So this will basically be my population. Okay, so this will basically be the population. Okay. Now, what I'm going to do, I'm going to take the class, let's say one class student's ages I'm going to take. I'm going to take, and then I'll probably find the mean of all the ages, and then we'll try to compare whether this will be able to give that specific output. Basically, can we come to the population mean ages of the college student? That is what I'm actually trying to do. Okay, so first of all, let's say that I'm having this code. Let's say this is there. Now everybody focus on the code. Here, this is a Poisson distribution. I'll talk about Poisson distribution tomorrow. It is just saying that you have to start from 18 age and the mean is 35, and we are going to consider our population ages as 1500. Then we are basically considering class A with starting age as 18, mean as 30, and size that is only 60 samples. Okay. So I'll talk about Poisson distribution, how it looks like in the tomorrow's session. Okay. Tomorrow's session will be quite amazing. Okay. So in this particular case, if I go and see school underscore ages, here is my value. And similarly, if I go and see class A ages, class A underscore ages. So this is my class A underscore ages, which are basically my 60 data. Okay. Now let's do something, one amazing thing. First of all, let's try to find out the class A underscore ages dot mean. So here you can see that it is 46.9. Okay. Now what I am actually going to do, I'm basically going to apply again this t-test. Where is my t-test? T-test one samp. Okay. T-test one samp. And here my first data will basically be my class A ages. Okay. And then the second parameter will basically be my mean. My mean, I will try to give this specific mean, school underscore ages dot mean. Okay. So this will be a parameter. If I go and see over here and press shift tab, you will be able to see that the second parameter I have to give as mean. This is nothing but my pop mean. Okay. Now here you can see that I'm getting the p value as this one. So tell me whether this needs to be accepted or rejected. Okay. Just tell me. And if I go and probably see the school ages mean, it is far away, right? It is 46.9 and this is 53. If you're considering alpha is 0.05, it will obviously be very, very far. Right? I hope you are able to understand. Right? So similarly, you have to reject it, guys, not accept it. Okay? Because this is way higher than that. You have to basically get p value less than the significance value. Okay? So let's say that I am putting this nearer to the class A mean. Let's see what will happen. 47. It is coming somewhere here. Oh, sorry, I have to give this as my sample mean. Okay. So like this, you can basically check out all the things and verify it. Whatever we have done. Okay. There is one more example with respect to chi-square test, which I probably also want to show it to you. But yes, today I have less energy. Let's do it tomorrow. Okay. So tomorrow I will do with respect to chi-square test, but I hope you got an idea about different things. Okay. And yes, that was it. I hope you like this particular video. Guys, sorry. See, one thing is that, okay, it is 10 raised to minus 13. It should not be rejected. Guys, it is 10 raised to minus 13. I'm extremely sorry. Okay, it should not be rejected. 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 So that is the reason what we do. We can put if. Okay. So here I will just say underscore comma p underscore value is equal to this. So if I say if p underscore value is less than 0.05, then what we do? Print. Tell me the message. Till then I'll write the else condition. Else print. Tell me what I have to write over here. Accept or reject. Again, people are getting confused with respect to accept. Again, people are getting a lot of confusion. Okay. Accept H0. Okay. So what I'm actually getting over here? Okay, guys. Thank you. So this was it from my side. Definitely check it out. All the time you need to check it out because here I missed something like this, right? Clear, guys? So overall, how was the session? Please rate it. Yes, it will be shared. Okay, one more final thing that I probably missed out. Let's say that I'm using Seaborn. Again, people are saying, Chris, you did not teach that, this, that. No one wants to try anything. Okay. So df is equal to because I need to show you correlation and all also. So we'll check out that also so that you'll be able to check it out. Okay. So SNS dot load underscore data set. Let's consider that I'm going to use iris data set. Okay. So this will be my df dot head. So if I use the correlation df dot corr, so this is how my diagram looks like. Okay. Here you can see that it is basically showing you the correlation with sepal length and petal length. It is positively correlated. Now see, with respect to correlation also we have various ways. Okay. We have various ways. Okay, I'll not use in this. Instead, I can also use sns dot pair plot df. So here also you have a way to see in a diagrammatic way. Okay. So here you can see this is how your diagram looks like. Okay. The entire correlation in visualized way. Okay. People are having confusion with respect to p value. Are you having confusion with respect to this? Have I done any mistake? Let me just confirm it. Oh, yeah. Guys, this will be reverse. Sorry. I made one mistake. Okay. P is less than this. Statistic indicates strong evidences against the null hypothesis as there is less than 5% probability the null is correct. Okay. It should basically write less than or equal to 0.05. Okay. So this was the small mistake that I did. Okay. Don't get confused. I know. Or I'll repeat this tomorrow. Okay. If p value is less than the significance value, then we reject because it statistically shows. Okay, sure. I will explain this part again tomorrow. Okay. Yes, if it is less than alpha, we have to reject, else accept. Yes. Here also I have written in this way only. So I have written it correctly over here, but in the code I have written wrong. Okay. If p value is less than the significance value, we reject. Okay. Code wise, but this wise, I have written it correctly. I have the proof. I was correct here. I was correct here. Okay. You made 1 hour mistake, I guess. No, no, no. Here correct it is, no? See? So here I was correct. In the code, I made some mistakes. Sorry, this should also be rejected. I don't know. Today, this should be reject. This should be accept. Anywhere I made a mistake here again? Okay, here also I think accept, here reject. Accept has become. Okay. Don't worry, I'll try to repeat it tomorrow. I think I made some confusion with respect to p value. Okay. In statistical significance, if the p value is less than 0.05, typically it is statistically significant. It indicates stronger evidence against the null hypothesis, as there is less than 5% probability that the null is correct. True. I made one mistake, guys. Again, I'm going to repeat it. See, if p value is less than or equal to 0.05, in this particular case, we reject the null hypothesis. The reason why we do this, because p is basically defining the probability part, right? Now in this particular case, they are just saying that it is less than 5% probability that the null is correct. It basically says that 5% probability the null hypothesis is correct. This will be applicable in coding, guys. So don't worry, in coding. Okay. So this is what it is basically saying. Okay. So if p is greater than or equal to 0.05, here we accept the null hypothesis, which in turn is saying that more than 5% probability, uh, there is a chances of more than 5% probability for the null hypothesis is correct. So this is basically for alpha 0.05. Okay. I hope now it is clear. Here I have written it anywhere wrong so that this gets solved. This is fine because this is greater than 5.99. Only the relationship between alpha, p value and alpha is important, guys. See, in coding, we always get a p value, right? So here also, if I go and see with respect to the coding, let's say in this particular case, if I'm getting 0.015, this basically indicates that, what does it indicate? We have to reject the null hypothesis. So here also I will just write a condition saying that this condition will work over here. Okay, same condition. Okay, don't worry. What I'll do tomorrow, whenever I get time, I will repeat this again. Okay, extremely sorry. It is always a confusing thing, p value, because p value I defined in that particular way. Everything is correct. Because see, what exactly p value basically specifies. I'll talk about it. I told you an example of mouse bar, right? If I have like this, here if I say p value is 0.8, that basically means out of all the 100 touches, 80% of time you're going to touch over here. Okay, out of all the 100 criteria, if you say p value is 0.01 over here, one time you are saying. Now if you are saying p value is less than 0.05, that basically means you have less than 5% probability, less than 5% probability for the null hypothesis to be true, which is basically present over here. Okay, perfect. Okay, p value less than or equal to 0.05 basically is specifying your tail region, and this is specifying your this confidence interval region when the p value is greater than or equal to 0.0, greater than 0.05. Okay, okay, I will repeat this, don't worry. I think I made a silly mistake today. In live sessions, it usually happens when we are solving multiple problem statements. Okay. Perfect, guys. So let's do one thing. Let's come tomorrow. Today I am super tired, and probably I also need to make some videos. Okay. Yeah, I will try to repeat all these things. Now, here also, apart from this condition, our thought process is absolutely fine, right? So, there is very less probability for this to reject the null hypothesis or accept the null hypothesis. Okay. Similarly, I've shown you this graph also. This graph basically specifies your correlation. Okay. And probably we have completed everything. Fine, guys. I made some mistakes, but definitely we'll check out in tomorrow's session and try to convince you in this also. But yes, simple. I still feel bad about myself. I was not able to, uh, you know, everywhere I teach properly this one, but always understand this relationship between p value and significance value. Significance value specifies your confidence interval. Okay, p value is from the test result. If this is less than or equal to ci, the confidence interval, or in this particular case the significance value, here you specifically reject the null hypothesis, because it is just saying that less than 5% probability it is there. Okay, so we reject the null hypothesis, and in the other case we accept the null hypothesis. Okay, when the p value is greater than alpha. Okay. Okay, a lot of confusion, but I will take it tomorrow. The first thing, I will start with p value thing only. First topic tomorrow will be to make you understand the differences between p value and significance value. Okay. Okay, guys. So this was it from my side for today's session. I will see you all in the tomorrow's session. Tomorrow is the probably the last session. Whatever things we want to summarize, we'll be able to summarize tomorrow. Thank you, everyone. Have a great day. And keep on rocking. Keep on learning. Bye bye. Keep on learning and try to help others. Thank you.